Now next topic is right circular cylinder. Now right circular cylinder is a cylinder whose guiding curve is a circle. So in this case the generators are normal to the plane of the circle. So in this case the base of the cylinder or the guiding curve is a circle. So it is clear here that the generator of this cylinder will be at constant distance from the axis of the cylinder. This fixed line is axis about which generator rotates and touches the base, that is circle here. Now if the radius of the circle is r, then the radius of this right circular cylinder will also be r. Now we have to find the equation of the right circular cylinder. Let us take a point A on the axis of the cylinder, alpha, beta, gamma, and general point P on the surface of the cylinder, x dash, y dash, z dash. We join the point A and P, and then we drop a perpendicular from point P to the axis, that is PM. Now here the triangle A and P will be a right triangle. So in this right triangle, using the formula or using Pythagoras theorem, we have AP square equal to AN square plus BN square. Now the equation of the axis of the cylinder will be the equation of the line passing through 2 points A and P and having direction ratios L and P. This will be x minus alpha upon L, y equal to y minus beta upon M, equal to z minus gamma upon N. So in this equation, AP is the distance between these 2 points A and P. AN is the projection of this line AP on the axis, and PN will be the radius of the cylinder. So AN square is the projection of line joining 2 points A and P. These are 2 points A and P on the axis of the cylinder, whose direction ratios are L, M and N. So AN square will be L x dash minus alpha plus M y dash minus beta plus N z dash minus gamma whole square upon L square plus M square plus N square, and AP square is the distance between 2 points A and P. So this is x dash minus alpha whole square plus y dash minus beta whole square plus z dash minus gamma whole square, and PN is the radius of this base circle or radius of right circular cylinder. So putting all these values of AN square, AP square and PN square in equation 2, we get the locus of x dash, y dash and z dash, and that is the required equation of the right circular cylinder. Now in particular case, if we have to find the equation of right circular cylinder whose axis is, if axis is x upon L, y upon M and z upon n. Then putting alpha beta gamma equal to 0, we get the required equation of the right circular cylinder as L square plus m square plus n square x square plus y square plus z square minus r square equal to lx plus my plus nz whole square. If origin lies on the axis of the cylinder, and also the equation of right circular cone whose axis is z axis. I am writing here, for axis is z axis, we have L, m equal to 0 and n equal to 1. So putting this L, m equal to 0 and n equal to 1 here, we get the equation x square plus y square equal to r square. So this is the equation of the right circular cylinder whose axis is z axis. Now let us see some examples on this. Now first example is to find the equation of right circular cylinder of radius 2 where axis passes through the point 1, 2, 3 and direction cosines are proportional to 2, -3 and 6. So the solution will be same as we done in the article. Now the equation of the axis passing through the given point and having direction cosines proportional to 2, -3, 6 will be x minus 1 upon 2, y minus 2 upon -3 and z minus 3 upon 6. And here radius is 2. Now let x dash, y dash, z dash be any point on the cylinder on the surface of the cylinder. Then as we done in the article, this is a cylinder, this is axis, this is a point x dash, y dash, z dash, and let given point is A, 1, 2, 3, and we draw perpendicular on the axis, that is N. So we have AP square equal to AN square plus PN square. Now AP square is distance between these 2 points A and P. So this AP square is x dash minus 1 square plus y dash minus 2 square plus z dash minus 3 square. AN is projection of line AP on the axis. So this will be x dash minus 1 multiplied by 2 plus y dash minus 2 multiplied by minus 3 plus z dash minus 3 multiplied by 6 upon, and this is whole square upon L square 4 plus 9 plus 6 square 36 and plus Pn. Pn is radius, so Pn is 2 square 4. So on arranging these terms here, arranging these terms and finding the locus of, hence the locus of x dash, y dash and z dash will give the required equation of the right circular cylinder, that is 5 multiplied by 9x square plus 8y square plus 13z square plus 12xy plus 3yz minus 2zx minus 14 3x plus 20y plus 9z plus 294 equal to 0. So this is the required equation of the right circular cylinder. Now let us see one more example. In this example we have to find the right equation of the right circular cylinder described on the circle through the points A 0 0, B 0 B 0 and C 0 0 A. Oh, sorry, this is here also it is A as guiding curve. So here we have 3 points and let the 4th point be taken as the origin. Then the equation of the sphere, with 4 points O, A, B, C is given by x square plus y square plus z square minus ax minus ay minus az equal to 0. This I told you in the lecture of the sphere. And the equation of the plane ABC will be, ABC is a plane through the section of 3 points A, B, C. So intercepted form of the equation of the plane through these 3 points will be x upon A plus y upon B and A plus z upon A equal to 1, and this implies x plus y plus z equal to A. Now therefore the guiding curve circle is given by the equation 1 and 2 together. Now since cylinder is right circular cylinder, hence the axis of the cylinder will be perpendicular to the plane this of the circle, and thus the direction ratios of the axis of the cylinder will be equal to, so direction ratios of axis of cylinder will be 1 1 1. Since here direction ratios of this plane normal to this plane is 1 1 1 and axis of cylinder is perpendicular to this plane, so the direction ratios of axis of cylinder and normal to this plane will be parallel to each other. So we have this thing. Now let Px1, y1, z1 be any point on the cylinder. Then the equation of the axis, the generator through this point will be x minus x1 upon 1, y minus y1 upon 1, and z minus z1 upon 1. Now any point on this generator, this will be r plus x1, r plus y1, and r plus z1. Now since the generator meets the guiding curve, so this point will satisfy the equation of circle given by 1 and 2, and so we have putting these points in equation 1 and 2. So we have r plus x1 whole square plus r plus y1 whole square plus r plus z1 whole square minus a r plus x1 minus a r plus y1 minus a r plus z1 equal to 0, and putting this in equation 2 we have r plus x1 plus r plus y1 plus r plus z1 equal to a. So on arranging the terms here from this equation, from 4 we get 3r square plus r 2x1 plus 2y1 plus 2z1 minus 3a plus x1 square plus y1 square plus z1 square minus ax1 minus ay1 minus az1 equal to 0, and from equation 5 we have r equal to 1 by 3 a minus x1 minus y1 minus z1. So from these two equations, on eliminating r between equation 6 and 7, putting the value of r from equation 7 to 6 we get, and obtaining the locus. Now if we eliminate r between equation 6 and 7, and on simplification we get the equation of the type x1 square plus y1 square plus z1 square minus y1 z1 minus z1 x1 minus x1 y1 equal to a square. So the locus of the point P x1 y1 z1, that is the required equation of the cylinder, is given by x square plus y square plus z square minus yz minus zx minus xy equal to a square. So this is the answer. So in this lecture I have completed the right circular cylinder and 2 examples on this topic. Thank you.